Coriolis effect. They like this one too. Wow.
Sixth grade Earth Science. My
Oh
first day
man.
on the job.
So here's what Wiki has to say about the Coriolis effect. In physics, the Coriolis force is an inertial or fictitious force that acts on objects that are in motion within a frame of reference that rotates with respect to an inertial frame. In a reference frame with clockwise rotation, the force acts to the left of the motion of the object. So here is a an interesting quote. I think it's from a might have been a meteorologist. So this is talking about jet streams and how the supposedly the Coriolis effect affects them. So you want to read this one, or is it too long for you?
No, I can read it.
Can you read that much?
Yeah, let me zoom in. Yeah. The
Yeah, yeah.
rotation of the Earth also affects weather through the Coriolis effect. Named after a French mathematician, this effect refers to the curved path that objects moving on Earth's surface appear to follow because of the spinning of the planet. As the Earth turns, points near the equator are moving faster than places near the poles, returning the Coriolis effect. Let's say returning, yeah, returning to the Coriolis effect. Think of the wind near the equator. The wind starts at a certain speed due to Earth's rotation. As the wind travels towards the North Pole, it moves over parts of the Earth that are rotating more slowly. The traveling wind retains its angular momentum and keeps moving west to east, overtaking the part of the Earth turning more slowly below it. This leads to the wind appearing to bend to the east. This effect is also responsible for why hurricanes in the northern hemisphere spin counterclockwise, while hurricanes in the southern hemisphere spin clockwise.
Are you sold?
That was what I was told to read back in the day.
Yep, yep, yep. So here's something that a lot of people bring up. I thought snipers had to account for the Coriolis effect. And I even had somebody that I don't know if they have a sniper rifle, but they like their Second Amendment rights, and
Mhm.
they have some rifles. I don't know how long range. So, and they were getting at it with me about this. So here, let's hear from somebody that has been a firearms instructor. So this is a quote from a really awesome book called "The Greatest Lie on Earth: Proof That Our World Is Not a Moving Globe," and it's from pages 139 through 140. This author, so he's talking about himself, obviously, is a former federal firearms instructor. I have seen many thousands of rounds shot from all kinds of firearms at various distances. I've never witnessed any round fired ever be affected by the alleged Coriolis effect. I've never read the Coriolis effect discussed in any firearms manual, nor have I ever heard it be discussed by any firearms instructor as something to consider in the use of any firearm from any distance. So you would think that a federal firearms instructor might need to say something about the Coriolis effect to somebody that's shooting really long range, because they would have to account for it. And they'll even, I think the movies, I used to like this movie back when I watched like Hollywood movies, but it's The Shooter. I think it's Mark Wahlberg, and he's a former maybe Navy sniper. And of course, he has to drop in there. You have to adjust for the Coriolis effect. And he's talking about all these atmospheric conditions you have to account for when a sniper actually shoots, because it doesn't just go straight. Stuff in the air and the atmosphere affects its flight. So that's a good example of how they program you, and they keep dropping those nuggets in your subconscious to keep reinforcing what we've learned since about age 5.
Mm-hmm.
I'm sure you've heard this one before because you've been at it a lot longer than me.
Yeah, that was one of the things. I was talking to a guy and we got to debating it, and he was a long range like sniper, and I'm thinking, you know, you also have to factor in which direction you're facing,
Yep.
because if we're that small on this moving ball, if we're facing north, that's going to make a difference whether we're facing south or east or west. It'll make a difference which way you're facing when you fire your shot, and they don't factor that in. And it's interesting that something as fast as a bullet would have to factor it in at those distances when helicopters, planes, anything else that's moving, hot air balloons, nothing really ever is encountering that. And the world, like they said, is moving at different speeds at different parts. So when I flew from the northern hemisphere to the southern hemisphere, I was landing on a runway that was moving at a different speed, right?
Yep.
And they never have to adjust for that. When you go north to south, you're going to places that are going different speeds from the ground that you left. Even if it's just 5 miles per hour, it's a different speed.
Oh yeah.
And I know that we used to jump off the treadmills while they were moving at 7 to 10 miles an hour. And that's almost like you can't even land on your feet.
Oh no.
They're doing that all the time, and it never affects them. You know, astronauts coming back down from 200 miles away and that Earth moving 1,000 miles per hour after they were moving 17,500, and there's never any accounting for anything. They just hit the water and there's a splash, and that's it.
Or you have another example. You can have a drone just flying there, and if
Yeah.
you leave it alone, if it's not getting hit by some really heavy wind, it'll just sit there and stay in that spot.
Yeah. And a lot of people will bring up, well, if you're on a train and you throw up a paper ball, you can catch it. And that is 100% correct. But we're not on a train going in a straight line. We're moving in a curved path. And not only are we moving in a curved path because of our spin, we're also moving in a curved path around the sun at 66,600 miles per hour. So those are different curved paths. There's no straightness to to our motion. We're never in a flat, level, straight path on the globe model. And when you take a drone, like you said, in a van, I watched a guy do this on a science channel. He put a drone in a van and he was driving, and the drone would just fly. But as soon as they would deviate from their straight path, that drone didn't know it. It would smack into the edge of the van. It was dependent on this van moving at a steady rate. If it stopped or did anything different, that drone, even though it was originally moving with it and laying flat on the surface, anything other than a straight path is what is noticeable, extremely noticeable, like instantly. And so our changes in speeds of the Earth's surface from plane flights would be a big one right there. We'd have to really, it would be in every flight manual, along with the curve calculations that they would have to calculate for based on their speeds as well.
And another example, let's say you're driving 60 miles an hour, and the passenger is holding a plate in their hand, and then you take this really steep curve. Is that plate just going to sit there, or is it going to go whoop and fly over? So when you have those directions, I mean, it affects it. And the Earth is, so that they say it's moving in so many different directions, you're going to feel it. So let's check out a short video about the Coriolis effect.
What about the Coriolis effect?
They say that the Coriolis effect is a result of the Earth spinning and is responsible for the deflection of an object moving above the Earth, rightward in the northern hemisphere and leftward in the southern hemisphere. The problem is that things like hurricanes and water in the sink aren't always predictable and have been known to spin both ways in either hemisphere. Also, another contradiction that proves the Coriolis effect false is the fact that no flying machine above the Earth has to account for it. If a bullet that travels 1,700 miles per hour has to account for the effect, then an airplane traveling at 550 miles per hour would definitely have to account for the effect. When you look for the answer, you'll find that we are told that since the atmosphere moves with the spin of the Earth, planes aren't affected. So why would bullets be? Especially when they go much faster than common airplanes.
We're in the middle of hurricane season, so this week's experiment is going to focus on these giant storms and why they spin. Did you know that every hurricane in the northern hemisphere has a counterclockwise motion to it? Well, let's find out why. Let's start off with the basics. The Earth is constantly spinning counterclockwise, even though you can't feel it. Even though you can't feel it. Even though you can't feel it. People in places along the equator are actually spinning faster than those closer to the North or South Pole. This is because they have a much greater distance to travel in one rotation than any other place along the Earth does. It is this inequality of speed that causes objects to turn, also known as the Coriolis effect. In the northern hemisphere, objects curve to the right, while in the southern hemisphere, objects curve to the left. But how does this affect hurricanes? Well, hurricanes are areas of low pressure. As we know, air always wants to move from high to low pressure, so it therefore gets pulled toward the low. As the air moves to the low in the northern hemisphere, it gets curved to the right via the Coriolis effect and creates the counterclockwise spin. Now for the experiment. You can make a hurricane at home by using a bowl of water, a spoon, and some food coloring. You'll want to fill your bowl about 3/4 full of water. Then take your spoon and spin the water around the bowl in a counterclockwise motion for a few seconds. Next, drop some food coloring into the center of the bowl and watch how it expands. It spins counterclockwise with the flow of the low pressure system. You might even see an eye start to form in the middle. Outer rain bands will start to form as well, and you'll notice they're going to spin faster than the water closest to the center will. Let me know if you're able to make one of these hurricanes at home, or if you have an idea for an experiment you would love to see me try and do. For News 19, I'm Danielle Miller.
So that is a cool experiment at the end with the food coloring, but that doesn't prove Coriolis effect. It is an interesting experiment.
Yeah.
But so I created a meme. I didn't pull this from somewhere else. I created this with all this in mind. So bullets, jet streams, and hurricanes are affected by Coriolis, but not planes. And I think you mentioned something about something similar earlier.
Yeah.
Couldn't resist. Had to do it.